So, what are zeros? Zeros are defined as the x values one might plug in order to make a function equal 0. So these are the values that you would plug in for x that, once you do the math, would make the whole thing equal 0, or make y equal 0, or f of x equal 0. So for example, if we have the function f of x equals 2x minus 3, and we wanted to find the zeros of this particular function, we need to find what we would put in for x in order to make this whole side equal 0, and therefore make the function equal 0. Now this one you might be able to just see what would work, but if you couldn't see what would work, what you do is you set the function equal to 0, because that's what we want to have happen when we pick the right x, and then to find the right x you do the algebra, move 3 over and divide by 2, so then you would get x equals 3 halves, and that would be the 0, 3 halves. The next bit of information that we want to discuss are the types of zeros. Types of zeros. You can categorize them into different ways. The main category that I think is important to note is that we could have real versus imaginary zeros. What that means is when you do this method above, setting equal to 0 and solving, you might find that your answers are real answers, or you may find that they're imaginary answers. A simple example of imaginary an equation that might give you imaginary zeros would be f of x equals x squared plus 1. So when you set that equal to 0, we get 0 equals x squared plus 1. Move the 1 over. We get negative 1 equals x squared, or x squared equals negative 1. And then we take the square root of both sides, not forgetting that we would have a plus or minus option there of negative 1. And the square root of negative 1 is defined as I, so then we get x equals plus or minus I. So that would be two imaginary roots. Now, an important thing to note here is because when you're finding imaginary roots, you end up taking the square root of both sides, we find that we always get two imaginary roots or zeros at a time. That's just always the case. But you could also get real zeros, as in the case before, where we have x equals 3 halves. People further define real as, or separate real into rational versus irrational, or positive real zeros versus negative real zeros, lots of other ways of looking at it, but that is the biggest division among zeros. The next thing to note is that the total number of zeros, will always equal the degree of the function. So recall that the degree of the function is the highest power of x in a function. So in this function here, the degree equals 2. And over here, this example, the first example, the degree there, we don't write it in, but it's x to the first power, so there the degree would be 1. This would be a linear degree, this would be a quadratic degree, and the total number of zeros will always equal the degree, no more, no less. So in this first one, we found the only 0, which was at 3 halves, and then the second one here, we have 2 zeros, and remember we have plus or minus, so that's 2 separate zeros, and those are the only zeros of that function. This is very useful when you're dealing with a function with a very high degree, and you can better keep track to know whether or not you found all the zeros. Now, let's look at another example of finding zeros. So here we're going to solve for zeros. Now, in this case, we took our function and we set it equal to 0. And then in the second case, we did the same thing. That is what we're going to do. That is the key here. That's the first step, set equal to 0. The next step will be to solve if it's simple like this one or this one, and if not, factor. So the next step would be solve or factor, depending on what the particular function required. If you solve that's great. If you can solve at this point, you get your answer. If you had to factor, the next step would be set each factor equal to 0. And then solve. And that would get you your zeros. In the example we're going to look at right here, we're going to go straight to the factored form. So here's our example. F of x equals x plus 1 times 2x minus 5 times x squared plus 3 times x plus 1. So here we can't see the degree of this function very easily, but we can look at the degree of each of the factors and imagine what we would get if we were to actually multiply all of those factors together. So here we have a degree of 1 times another factor with a degree of 1. That would get us a degree of 2. And then that multiplied by a factor with a degree of 2 would give us a degree of 4. Remember, we're adding exponents here. And then multiply that by one more with a degree of 1. That would give us a degree of 5. So in this case, the degree equals 5. Good to keep in mind when we get to our final answer to make sure we have 5 zeros. Now we're going to set each factor equal to 0. So we have x plus 1 equals 0. We have 2x minus 5 equals 0. We have x squared plus 3 equals 0. And we have x plus 1 equals 0. Now here, we move the 1 over. We'll find that x equals negative 1. Over here, we move the 5 and divide by 2. We get x equals 5 halves. And this one, which is similar to the one we did over here, our second example, but slightly different, will give us this factor, which is slightly different, will give us a slightly different answer. So let's go through that one. So move the 3 over. We get x squared equals negative 3. Take the square root of both sides. We get x equals plus or minus the square root of negative 3. And remember, when you have the square root of a negative number, you can pull out an I. So that means we have x equals plus or minus I root 3. Nothing we can do with that 3 there, so we're going to leave it there. And then finally, with this last factor, we have x equals negative 1 when we move that over. So those are our zeros. Let's list them out. So x equals negative 1, 5 halves, plus or minus I root 3, and negative 1. Notice, well, first of all, let's count. Make sure we have 5. So here's 1, 2. This one counts for 2, so that's 3, 4, 5. We have our five zeros. Notice that we have negative 1 showing up twice. This we call a double root, and sometimes it's nice to note that. So we write negative 1 and then dr for double root, so we can note that that's a double root. And then 5 halves and plus or minus I root 3.